Hi, Matthew here. I'm going to talk you through this Leaving Cert Maths question. It's challenging, but hopefully with my help, you'll be able to understand and answer the question. So let's get started.
We're going to look at question 2, which is a 30-mark question on the circle. So part A tells us that circle P has equation x squared plus y squared minus 8x minus 10y plus 9 is equal to 0, and circle Q has centre minus 2 minus 1 and radius 2 square root of 2. So A part 1 is worth 10 marks and wants us to show that circles P and Q touch externally. So if these circles touch externally, then the distance from centre P to centre Q should be equal to the radius of P plus the radius of Q. So we're going to have to work out the distance from centre P to centre Q, and we have the centre of Q, but we don't have the centre of P. So we're going to have to work out the centre of P from the equation that we've been given. And just to remind you how to work out the centre when we're given an equation of a circle like that, I'm going to show you page 19 of our formula and tables book. So we've been given an equation in this form, and the centre is going to be minus g minus f, with 2g being the number before the x and 2f being the number before the y. Now it's important, it's not the number before the x squared or the y squared, it's just the x by itself and the y by itself. And then the centre is minus g minus f. So in our case here then, 2g is going to be equal to minus 8 and 2f will be equal to minus 10. So if 2g is equal to minus 8, then dividing both sides by 2, we get g is equal to minus 4. And then 2f is equal to minus 10. And again, dividing both sides by 2, we get f is equal to minus 5. But remember, the centre is minus g minus f, so minus g is equal to 4, and minus f is equal to 5. So therefore, the centre of P is equal to 4, 5. So now we have to work out the distance from the point 4, 5 to minus 2, minus 1, and we can do this using the formula on page 18 of our formula and tables book, the distance between 2 points. So it's this formula right here. So when we have our two coordinates, x1, y1, x2, y2, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And now we're going to use this formula to work out the distance between the two centres. So we're going to label 4 as x1 and 5 as y1, and then minus 2 as x2 and minus 1 as y2. So then it's equal to the square root of minus 2 minus 4 squared plus minus 1 minus 5 squared. So now evaluating that, we get the square root of minus 6 squared plus minus 6 squared, which is the same thing as the square root of 36 plus 36, which is equal to the square root of 72. And the square root of 72 can be written as 6 square root of 2. So that's the distance between both of the points. Now what we have to work out is the radius of P, and again we have a formula for this. So the centre is minus g minus f, however the radius is the square root of g squared plus f squared minus c, with c being the constant in the equation. So let's use this now to work out the radius of the circle P. So remember the square root of g squared, which is 4 squared, plus f squared, which is 5 squared, and then c in our question here, let's see. So it's the square root of 4 squared plus 5 squared minus 9, and that's equal to the square root of 16 plus 25 minus 9, which is equal to the square root of 32. So that's the radius of P, but remember, we have to work out the radius of P plus the radius of Q, so that's going to be square root of 32 plus 2 square root of 2, which we're given at the start of the question, and that will give us the radius of P plus Q, and this will give us 6 square root of 2. And therefore, we've shown that the distance between both centres is equal to both of the radiuses added together. They're both equal to 6 square root of 2. So therefore, we've shown that the circles touch externally. So that's our answer for question A part 1. And now we're going to have a look at A part 2, and this is worth 5 marks. So here we have to find the point of contact of the two circles. And to do that, I'm going to use the formula for the point dividing two other points in the ratio A to B. So we need to find the ratio between both of the circles. We know that circle P has radius square root of 32, but the square root of 32 is equal to 4 square root of 2. And circle Q has radius 2 square root of 2. So therefore the radius of that is just 2 to 1. And now our two coordinates are the two centres, so it's going to be 4, 5 and minus 2 minus 1. So now let's have a look at page 18 of our formula and tables book for the formula. So it's the very last formula on the page down here. So A and B is the ratio, in our case 2 to 1, and then x1, y1 is the first coordinate, and x2, y2 is the second coordinate. So let's use these now to work out our point. 2 is going to be A, and 1 is going to be B. 4, 5 is going to be x1 and y1, and then minus 2 minus 1 is x2, y2. So now putting these into the formula, we get 1 by 4 plus 2 by minus 2 over 2 plus 1, and then 1 by 5 plus 2 by minus 1 over 2 plus 1. So then the x coordinate is going to be on the top, it's going to be 1 by 4, so 4, plus 2 by minus 2, so minus 4. So that's going to be 0 over 2 plus 1, which is 0 over 3. And then the y coordinate will be 1 by 5, which is obviously 5, plus 2 by minus 1, which is obviously minus 2. So 5 minus 2 is 3 over 2 plus 1, so 3 over 3. So 0 over 3 is just 0, and 3 over 3 is 1. So therefore, the point of contact between both circles is 0, 1. And that's our answer for A part 2. Now we're going to move on to part B of the question. So part B is worth 5 marks, and it wants us to find the equation of the tangent to the circle Q at the point minus 4, 1. So let's have a look at our formula and tables book on page 18 again to see the formula for the equation of a line. It's this formula right here. So we need a coordinate on the line and also the slope of the line. We're given the coordinate, however we need to work out the slope now. So when you're trying to find the equation of a tangent to the circle, what you have to do is you get the slope of the center to the tangent. So you get the slope of that line, and then the slope of the tangent will be perpendicular with that line, okay? So whatever the slope is of the center of the circle to the point at which the tangent is at, the equation of the tangent will have a slope that's perpendicular with that, okay? So we're going to work out now the slope of the line from the center of circle Q to the point minus 4. And remember, the center of circle Q is at minus 2, minus 1, and then minus 4, 1. So again, we have a formula to work out the slope of a line, and this is in the formula and tables book, but I think you probably know it by now. So it's equal to y2 minus y1 over x2 minus x1. So we're going to mark in now x1, x2, y1 and y2. So minus 2 is x1, minus 1 is y1, minus 4 is y2, minus 4 is x2, and 1 is y2. So that gives us 1 minus minus 1 over minus 4 minus minus 2. So it's important to remember that a minus by a minus becomes a plus. So that's 1 plus 1, which is going to be 2 on top, over minus 4 plus 2, it's minus minus 2, so it's plus 2. So minus 4 plus 2, which is minus 2, and 2 over minus 2 is minus 1, and that's the slope of the line from the centre of circle Q to the point minus 4, 1. So now we have to find the slope that's perpendicular with that, and to find the slope that's perpendicular with the particular slope, you just flip the fraction and then change the symbol. So minus 1 is equal to minus 1 over 1. So to flip the fraction, that's still going to be 1 over 1. And it was negative, so now it's positive, and 1 over 1 is obviously equal to 1. So therefore, the slope of the tangent is equal to 1. So the slope is equal to 1, and then x1, y1 will be equal to a coordinate on the line. So the coordinate we have is minus 4, 1. So that means x1 is going to be equal to minus 4, and y1 will be equal to 1. So now we just have to pop these into the formula. So y minus y1 will be y minus 1. That's equal to m, which is 1, times by x minus x1, so x minus minus 4. So that's going to be y minus 1 is equal to 1 times by x, which is just x. And then 1 times by minus minus 4, so 1 times by plus 4, so it's going to be plus 4. And then plussing 1 to both sides, we get y is equal to x plus 5. And that's the equation of the tangent to the circle Q at the point minus 1, 4. So now we're going to have a look at part C. This is the final part, and it's worth 10 marks. So here we have to find out if the tangent that we found in part B is also a tangent to the circle P. So to do this, we're going to work out the perpendicular distance between the equation of the line and the centre of circle P. That should be equal to the radius of P if it's a tangent. If it's not equal to the radius of P, then it's not a tangent to the circle P. So we're going to use our formula in the formula tables book on page 19 to find the distance from the point to the line, and the point will be the centre of P and the line will be the equation of the tangent. So it's the very first formula on the page up here. So we're going to have to write the equation in the form ax plus by plus c is equal to 0, and then x1, y1 will be the centre. So the equation was y is equal to x plus 5, but now I'm going to rewrite that as x minus y plus 5 is equal to 0. So I've just changed it around slightly, and we already know that the centre of circle P is 4, 5. So a here is going to be 1, b is minus 1, and c is 5. x1 is 4 and y1 is 5. So now let's put these into the equation for the distance from a point to the line. So it's the absolute value of a times by x1, which is 1 times by 4, plus b times by y1, so minus 1 by 5, plus c, so plus 5. And remember, the absolute value means that the value must be positive. So whatever number we got here, we can turn it into the positive value. That's going to be over the square root of a squared plus b squared. So the square root of 1 squared plus minus 1 squared. So evaluating the top, it's the absolute value of 1 by 4, which is 4, plus minus 1 by 5, which is minus 5, plus 5, over the square root of, so 1 squared is 1, plus minus 1 squared is also 1, so the square root of 1 plus 1, so the square root of 2, And now evaluating the top we get, so 4 minus 5 plus 5 is just 4, and that's already positive, so we don't need to do anything with that. And it's going to be over the square root of 2. So that's the distance between the tangent and the centre of the circle P. It's not equal to the radius of P, so therefore it is not a tangent to the circle P. So that's our answer for part C of the question, the final part of the question, and the end of the video. So thank you very much for watching, and I hope I helped.